Hi, in this video, I'm going to introduce you to multi-layer switching. Okay, so what's the difference between a router and a multi-layer switch, also known as a layer 3 switch? Well, both routers and multi-layer switches perform routing. They make forwarding decisions based on the layer 3 IP address. So here we have a router. Write that right there. And here we have let's say it's a multi-layer switch, a layer 3 switch. So one thing you might notice is that routers have different types of interfaces, not just Ethernet, but may have serial interfaces as well. ATM interfaces, those are a little bit of legacy, but other types of non-Ethernet interfaces. While multi-layer switches, layer 3 switches we call them, will have just Ethernet interfaces. Okay. Routers are also used to segment LANs, similar to a multi-layer switch, but they're also used at edge-facing devices. So looking at this network here, we can see these are multi-layer switches. Multi-layer switches typically have all internal facing devices with only Ethernet interfaces. Routers, on the other hand, these devices here, will include other features and other functions, including wide area network interfaces, performing NAT, firewall features, and other edge functions. Multi-layer switches typically don't have all these features found in routers. Now, you may say, well, they still sound very similar, and why can't a multi-layer switch do what a router does? And it really comes down to a marketing thing, a marketing term. And yes, you can kind of have a multi-layer switch that has all the features associated with Ethernet interfaces put in the same box for a multi-layer switch that you'd find in a router. So again, we see a little fuzzy area here between what a multi-layer switch is in a router. And by the way, a lot of times now, so many of our switches now are multi-layer switches. A lot of times when we refer to a switch, we're now thinking, a lot of podcasts, a lot of readings. When they say switch, guess what? Sometimes they just mean by default a layer 3 switch. How things continue to change. Okay. So in the old days, we had a dedicated router. On the left here, you can see it's a router on a stick in this case. So any traffic sent from VLAN 10 to VLAN 20 would have to be sent to the switch across the trunk link where it actually gets routed and sent back to VLAN 20, because the switch here just does layer 2, does no layer 3, this typical layer 2 switch. Okay. So we require either trunk links or multiple links to forward traffic between our switches and our routers and back down, in this case, towards those same switches. Now routing can be performed at wire speed in the multi-layer switches. So now we can use multi-layer switches to do the routing for us internally. We're going to see how this works in just a moment. But multi-layer switches have two types of ports, either a routed port or a switch virtual interface port. So here we see switch 1 and switch 2 are just access switches, and what they're showing in this example here is this topology here is these are just layer 2 switches. Our distribution switches nowadays are typically multi-layer switches, and this is where the routing actually occurs. So going from a device in the red VLAN to a device in the blue VLAN gets routed here by the multi-layer switch. So I mentioned that there are two types of ports, routed ports and switch virtual interfaces on a multi-layer switch. We'll talk more about this in the next couple of slides. You'll see exactly what I mean by this. But on a multi-layer switch, a routed port is just like a port on the router. It has a dedicated IP address and prefix length assigned to that port, and it's a member of that subnet. It's just like a port on a router. A switch virtual interface is a logical interface inside the switch. All switch ports that are a member of a specific VLAN can communicate with that switch using that IP address. We'll see what we mean by that in just a moment. The SVI is typically used as a default gateway for devices on that VLAN or subnet. Let's make sense of this in this next couple of slides. So here, I'm going to show you a switched virtual interface. All right. So let's bring up the pen here. All right. So we have this switch here. Let's say these ports here are configured on VLAN 10 and these ports here on VLAN 20. All right. So all the switch ports are assigned to those specific VLANs. Now remember, our PCs, our end devices, they don't know what VLAN that they belong to. They're assigned with an IP address. So we have these two, say host A and host B on the same subnet. Now notice that their default gateway, they have 172.16.10.1 as their default gateway. On the switch, we have configured, first of all, these ports here belonging to VLAN 10, but we say interface VLAN 10. I'm going to come back to this switch port command in a moment. We assign it an IP address. Notice that this is the default gateway address used by devices on that VLAN. Did no shutdown. Now the switch port command is something we don't need to use on most switches. Switch port is the default. Switch port means that this interface is operating as a layer 2 interface. Okay, now it does that the interface itself is layer 2, that it is not a routed port, as we'll see here in a moment. Okay, so notice on our VLAN 20 here, those switch ports, VLAN 20, we've done similar. We've assigned this VLAN an IP address 172.16.20.1, which is the default gateway used by these devices. Okay, so this switch already has now 2 IP addresses associated with it, okay, and can actually route from devices, let's say on VLAN 10, can actually then forward traffic to devices on VLAN 20 or out other interfaces as well, as we'll see here in the next screen. So these are known SVI, switch virtual interfaces. These are logical interfaces inside the switch. All right, let's take a look now at what a routed port is. A routed port, we said, is just like a physical port on a router. Okay, so here I have 2 interfaces. Here, gig 01, let's say this is gig 02. And notice that they'll each have a separate IP address. So let's take a look here. So we come down here, interface gig 01, we say no switch port. This converts it to a layer 3 physical or layer 3 routed port. Okay, no switch port. Now we assign it an IP address. So that's just like a port on the router. Okay. Same thing with the gig 02 port. We've made it a routed port, no switch port, and assigned it an IP address. This is just like we would do on a router, right? So when we say no switch port, we're now, think of it as like a port on a router. Okay. So in this case here, gig 01 is 172.30.1. And so let's say it is connected to, could be a multi-layer switch, but in this case, it's a router. Okay, and it is on the same subnet, the same /30 subnet, 172.60.30.2. And we do routing here, reporting traffic, just like we would with a router. Okay, so I hope that helped as far as an introduction to multi-layer switching, the difference between a switch virtual interface and a routed port.